Hello, grade 7 students. Another exciting learning day today. Welcome to our radio-based instruction for Science 7, Quarter 3, Week 2. My name is Teacher Yong. Today, we are going to discuss describing motion. In this lesson, you will identify the types of speed, differentiate speed from velocity, describe the object's acceleration, explain why any change in the velocity of an object results in acceleration, and relate the concept of motion in real-life situation. I know you're very excited to learn, so what are we waiting for? Get your pen and paper and your weekly learning activity sheet. And together, let's describe motion.
Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone. Learning science is fun, knowledge for everyone.
You are surrounded by many things that move in different directions. In our previous lesson, you have learned about describing motion in terms of how far the object travels relative to its reference point. In this lesson, you're going to describe motion in terms of how fast the object travels. The terms speed and velocity are used interchangeably in everyday situations. However, in physics, they have distinct meanings. Speed is a distance traveled by an object per unit of time, and it is a scalar quantity. When the speed of an object is associated with direction, the result is the velocity of an object. Velocity is a vector quantity. The speed is the magnitude of the velocity of an object. The SI unit of speed and velocity is meter per second with a symbol m/s. An object normally changes speed while moving. Hence, it is necessary to determine the average speed. It is the total distance traveled by an object divided by the time spent by that object in traveling the total distance, which means average speed equals total distance divided by total time. Average speed is usually measured in meters per second, or m/s, or kilometers per hour, while total distance is commonly expressed in meters and/or kilometers. Total time is commonly expressed in seconds or hours. Now try to think of a vehicle moving along Macapagal Bridge, which begins slowly for the first 30 minutes and speeds up for the first hour. Traffic congestion in the area may cause changes in speed of the vehicle many times throughout its journey. Dividing the total distance traveled by the total time spent in traveling does not tell you the speed of the vehicle for every point of its journey, but it gives you the average speed. Let's try this first problem. John, who is driving to Robinson's Mall Butuan, travels 200 meters in 300 seconds. Then, he goes to SM Butuan, traveling an extra 400 meters in 500 seconds. What is his travel's average speed? Now here's the solution. Step 1. Find what are given and what is asked. The given are the total distance, which is 200 meters plus 400 meters, a total of 600 meters. The total time John traveled is 300 seconds plus 500 seconds. That's a total of 800 seconds. Let's try to find out what is the average speed. Step 2. Solve for the equation by just substituting the given values. As simple as that. You are going to use the formula I gave earlier. The average speed is equals to the total distance divided by the total time. The total distance is 600 meters divided by the total time, which is 800 seconds. That gives us the average speed of 0.75 meters per second. Therefore, the average speed for John travel is 0.75 meters per second. Easy, right? If you solve for the distance traveled by an object over the time it took to cover such distance, then you have computed for the average speed. During its travel, there were instances that its speed would vary. Its speed at an instant is called instantaneous speed. This may be greater than, less than, or equal the average speed. Similarly, the velocity at an instant of a moving body is called instantaneous velocity. When we are referring to the constant motion or when the object's instantaneous speed values are always the same, we mean this as constant speed. Where you will be and what time you will reach your destination is easily predicted when you move at constant speed or velocity. Are you familiar with speedometer? Speedometer is a device used to measure the instantaneous speed of a moving vehicle. This device is much important to the drivers because they need to know how fast or slow they are pacing so they know if they are already driving beyond the speed limit or not. The direction of which an object moves is another important characteristic of motion. For example, a car from the garage is moving to the north along a straight highway. It stopped after an hour for refueling at a gasoline station 80 kilometers away from where it started. How will you describe the motion of the car? The rate of motion of the car is 80 kilometers in 1 hour, northward, or 80 kilometers per hour northward. This represents the velocity of the car. In symbols, V equals velocity, D is displacement, and T is elapsed time. That's velocity equals to displacement over elapsed time. Let's try this in sample problem number 2. Manny travels a distance of 40 kilometers south from his town to Butuan City using his car. What is his average velocity in kilometers per hour if traveling time is from 7 a.m. to 7:30 a.m.? Here's the solution. Step 1. Find what are given and what is asked. The given is the displacement, 40 kilometers south. Elapsed time is 30 minutes. Because it takes 30 minutes from 7 a.m. to 7:30 a.m. and 30 minutes is equivalent to 0.5 hour. What is its average velocity? Step 2. Solve for the equation just by again substituting the given values. And we are going to use the formula I gave earlier. That's average velocity is equal to total displacement divided by elapsed time. Now the solution is as simple as the total displacement is 40 kilometers divided by the 30 minutes from 7 to 7:30 a.m., which is equivalent to 0.5 hour, which gives us 80 kilometers per hour. Therefore, the average velocity for Manny's travel is 80 kilometers per hour. As easy as that. In real world, objects move with changing velocities. A car seldom travels with constant velocity for long. Sometimes it speeds up or slows down. A new concept called acceleration has been defined. Acceleration is the term we refer to the change in the object's velocity with respect to time. Velocity can change in three ways. A. Change in speed, either increasing or decreasing. B. Change in direction. And C. Change in both speed and direction. Acceleration equals change in velocity over time, or acceleration equals change in velocity expressed in meters per second over change in time expressed in seconds, equals to final velocity minus initial velocity over final time minus initial time. Acceleration is also a vector quantity since it is determined in terms of velocity. The SI unit of acceleration is meter per second or meter per square second. For uniform motion, the velocity is uniform throughout the motion or it is constant. The acceleration is zero, and the instantaneous velocity is equal to the average velocity. Its displacement may be obtained by multiplying its constant velocity by the time. D equals V times T. Uniformly accelerated motion, or UAM, is a more common type of motion in which velocity is changing at constant rate. Acceleration here would mean change in speed rather than change in velocity. That is, acceleration equals to final velocity minus initial velocity over time. Now, to help us understand more, let's have sample problem number 3. Mang Ben's vehicle is stopped at a traffic light. When the light turns green, the driver accelerates so that the car's speedometer reads 10 meters per second after 5 seconds. What is the car's acceleration assuming it has a constant velocity? Here's the solution. We are given that the initial velocity is equals to 0 and the final velocity is equals to 10 meters per second at a 5 seconds time. Substituting these values in the equation for acceleration, we have acceleration is equals to 10 meters per second minus 0 divided by 5 seconds. That gives us 10 meters per second divided by 5 seconds equals to 2 meters per second over second, or 2 meter per square second. Therefore, the car's acceleration is 2 meters per square second. Now come on, let's have our activities for this lesson. Let's begin with activity 1, Speedy Diary. All you need is your pen and paper. What you're going to do is to identify the different types of speed by just arranging the jumbo letters found on page 6 of your learning activity sheet. Can you see it? Very good. Alright, after having the correct words, write something that describes each type. Let's start. Can you now guess what's the word in the first box? Very good. It is average speed. It is the total distance traveled divided by the time spent in traveling the total distance. How about the second box? Great! It is instantaneous speed, or the object speed at an instant. Let's try the third one. Great! The jumbo letters is constant speed. It is the instantaneous speed that does not changes a long time. Can you try to answer these questions? What type of speed do you get when you are checking the speed of your single motor from the speedometer while driving? Very good. The answer is instantaneous speed. The speedometer is a device used to measure the speed of a moving vehicle. How important it is to have a functional speedometer in our vehicles? The device is called the speedometer. Let's now have our activity 2, entitled Velocity versus Speed. All you need for this activity is your pen and paper. This activity consists of 2 parts. Let's begin with the first one. Determine whether the following scenario shows speed or velocity. Write only S for speed and V for velocity on the blank provided on page 6 of your learning activity sheet. Let us start. Number 1. An old man walked along the street for half an hour and covered 1.5 kilometers. S or V? Very good. The answer is speed. S. Number 2. An elevator is moving up and down the luxury hotel for 2 minutes, covering 100 meters. S or V? Great! It's velocity. V. Number 3. The weather forecaster announces that the wind speed of a tropical depression is 80 kilometers per hour west of Surigao. S or V? Very good. It's velocity. V. Number 4. A ball dropped from a 30-meter high building is found on the ground after 3 seconds. Speed or velocity? S or V? Great! It's V. Number 5. A sprinter finished a 500-meter race after 2 minutes and 30 seconds. S or V? Very easy. It's speed. S. Now let's come to the second part of our activity 2. State what is measured in each item. Write speed if it is a speed and velocity if it is a velocity. Number 1. 100 kilometers per hour north. Yes, it is velocity. Number 2. 20 meters per second. Nice, it is speed. Number 3. 4.5 meters per second downward. Very good, it is velocity. Number 4. 50 centimeters in 2 seconds. You are correct. The answer is speed. And for number 5, 65 meters in 1 minute upward. It is speed or velocity? Great! It is velocity. Yes, and so that's it. That ends our lesson for today. You can now identify the types of speed, differentiate speed from velocity, describe the object's acceleration. You can now also explain why any change in the velocity of an object results in acceleration. And you can relate the concept of motion in real-life situation. Easy, right? That's how we describe motion. Once again, my name is Teacher Young, and that's our second lesson for Quarter 3 for Science 7. See you next time. Bye!